Okay, for the 9 and 10, you're given two different explicit formulas, and you're supposed to generate the first four terms of that sequence. When I look at number 9 is clearly arithmetic. It fits the form of it. I know the first term is 4, and it's increasing by 3. Now, if I wanted to, I could go through and I could say n is going to take on the values. N would be 1, n would equal 2, n would equal 3, and finally n would equal 4. And that'll give me the first four terms, right? In fact, if n is 1, if I put a 1 right here, you can see all of a sudden this becomes 0. 0 times 3 is 0, so all I'm left with is the 4, right? And I can continue this with all four of the terms, or the remaining three terms. But I know this is definitely an arithmetic sequence, and I know the common difference is 3. It's right there. So I can also just say, hey, the next one's going to have to be 7, the next one's going to have to be 10, and the last one's going to have to be 13. So those are the first four terms. Now, just, you've seen me do it on these videos. I can make mistakes and be wrong. I'm just going to go ahead and plug in 4 and just verify that I do get 13 for the fourth term. So if I do plug a 4 in right there for the fourth term, all of a sudden this becomes 4 plus 3, right? 4 minus 1 is 3 times 3. So I'm looking at 4 plus 3 times 3, which is 9, and 4 plus 9 is indeed 13. So yeah, that's nice. I just looked at it because, I make mistakes. Number 10, it is a geometric sequence. I can totally see the pattern there. Since it's geometric, we're going to go ahead and I know the first term has to be the number 4. And then every single time after that, it's going to be 1/2 as big. So I'm going to go from 4 to the number 2. 1/2 of 2 is going to be 1. And then 1/2 of 1 is going to be 1/2. So there's my first four terms, right? 4, 2, 1, and 1/2.